again. Section 11.1, area of parallelograms. This is part of your independent study packet that I passed out the other day. These lessons should be pretty quick and short, hopefully just kind of keying in on some of the examples that will model the problems that you'll see in your packet. So pretty much all the formulas are in your packet with each and every worksheet. So parallelograms, area of a parallelogram is just the base times the height. B represents the base, H represents the height of the parallelogram. Just some key points here. One, the height is always going to be an altitude, never the slanted sides. The slanted sides will never be the height of a parallelogram. The parallelogram will always be an altitude, starting at a vertex, dropping straight down, forming a perpendicular with the opposite side. The base will always be the side that the altitude intersects at that perpendicular, at that right angle. So here you can see you've got my height, intersects this side right here at a right angle, so this is the base, which means that this top segment, the top side, would also be considered the base, because obviously parallelogram, the opposite sides are going to be congruent. Down here, I'll give you another example. Notice this time my altitude starts in the lower left hand corner, comes perpendicular to the right side, which means that this right side would now be considered the base of our parallelogram. So some key points there for you. Came up with a couple examples that'll pretty much model the problems that you see on your worksheet. One right here, I've got a parallelogram, altitude coming up with a height of 7 meters. I know the length of this side is 12 meters, which means the length of the opposite side is also 12 meters. So the base is 12. Area, base times height, which means that the area is going to be 12 times 7, or 84 square meters. Big thing I want you to remember with your area, it's always in square meters. We're talking about area. We're talking about the amount of stuff I can fit inside the parallelogram. And so those are always going to be in square units. Square meters, square centimeters, square feet. Something to kind of keep in mind there. Make sure you always label your answers. Even if there's not any units, you should put square units. We'll talk about that here in a minute. Another parallelogram here in example 2. Here we know that our base has a length of 26 inches. We've got a side of the parallelogram that's 14 inches. We drop down this altitude from the vertex straight down. And we know that this one angle of our parallelogram is 60 degrees. And so what happens here is we start to form a right triangle. Kind of gets back into some 30, 60, 90 right triangle action, which means you need to know that this is the hypotenuse. Across from the 30-degree angle, which would be this angle up here, is our short side, and then our altitude here would end up being our long side. So to go from hypotenuse to short, we divide by 2. So this is 7. To go from short to long, we multiply by the square root of 3. And so our height is 7 radical 3 inches. So if I take height times base, 26 times 7 radical 3, basically all I'm going to do is take 26 times 7, come out with 182 radical 3, and that's square inches. And that's our area. So there I can just kind of leave the radical 3 on the end and just multiply the 26 and the 7 to get my area. You'll notice on your worksheet when you give a problem like this, it's kind of an odd shaped figure, like a staircase if you will. Your best bet here is to just break that into rectangles. Whether you break it into rectangles coming across this way, or whether you bring a line straight down here. But if you break it into rectangles, find the area of each rectangle, and then you want to add those together. So here I'd have area number 1, area number 2, area number 3. And so if I add those together, that will give me the area of the entire figure. Something else you'll notice, area of a shaded region. Here I've got a rectangle that's 12 by 8. Inside I've got a square that's 4 by 4. So all outside the square but inside the rectangle I've got shaded. I want to find the area of just the shaded part. So your best bet is to take the area of the rectangle, so base times height, which would give us 12 times 8, and that'll be 96. Take the area of the square, which is 4 by 4, so 4 times 4 is 16. And then I want to subtract those. To get the area of the shaded part, just subtract the part that's not shaded from the total, for the whole figure. And so that lets us know that our area is 80 square units, which I can just go U period and put my little squared symbol for units squared. One last example you have to worry about is kind of taking the formula for area and working backwards. So if the area of a parallelogram is 27 square meters, and if we know the height is 3 meters, what's the length of the base? So again, we know the formula for area, base times height. Here I know my area is 27 square meters. I know my height is 3. What I'm looking for is a base, simple division. I know that my base is going to be 9 meters long. So that should help you out. If you got any questions, feel free to rewind the video and take a look at some of the examples we talked about. Ask questions in class. We'll see you next time. Peace!